Oh, we can start with this number 5 and 10.4. We're supposed to simplify this expression. Think we can do it? How about 4 minus 7? How about negative 3? So what we're saying here is this. If you have one of these, the square root of 16, and you subtract one of these, the square root of 49, what have you got left? We've got negative 3 left. And in number 7, here's what we've got. We've got negative 4 of these square roots of 3. So how many square roots of 3 do we have? We're down 4. So negative 4 square roots of 3. And then we're going to add to that 8 of these square roots of 12. That doesn't look like a 12, does it? But it's supposed to be a 12. Let me write it so it's readable here. That's supposed to be a 12. So we're going to take negative 4 of these and add 8 of these. So here's how we're going to do this. We know we can only add like terms. These terms are not alike, but we can simplify this one. Watch this. Let's do this. Negative 4 square roots of 3 plus 8 times. Now, can you break that 12 down into two numbers, one of which you know the square root? Well, how about 4 times 3? So let's write this as 4 times 3. So we'll have negative 4 square roots of 3 plus 8 times. Now, we've got the square root of a product. We can break this into two square roots. Square root of the first times the square root of the second. So square root of 4 times the square root of 3. This will give us negative 4 square roots of 3 plus 8 times 2 square roots of 3. And now negative 4 square roots of 3 plus 8 times the 2, 16 of those square roots of 3. Okay, now what we've got is we've got square roots of 3 here, square roots of 3 here. We've got negative 4 here and 16. Now, what we're thinking is this. What's negative 4 and 16? It's 12. So we're going to have 12 square roots of 3. Now really, are you okay with that? I mean, if we had this, if you had negative 4x plus 16x, you'd be okay writing that as 12x. Instead of x, though, instead of x, we just have square roots of 3's. So let's see if we can break these down into something that has like terms. The numbers are kind of big, so it's going to be a little bit of a challenge, but 300 we might be okay with that. We can write as 2 times, well, how about 100 times 3, because I know the square root of 100. Now this is going to be minus square root of, now look, we know we're looking at 3's, so on your calculator you might do this. Take 108, divide it by 3, and sure enough, when you do that, it goes in 36 times, and you know the square root of 36, so we'll get 36 times 3 plus 4 times. Now, let's do the same thing with that 192. You know we want a 3 over here. So take 192, divide it by 3, and you get 64, and sure enough, we know that square root of 64. Now, we're going to get 2 times the square root of 100 times square root of 3, minus square root of 36 square root of 3, plus 4 square roots of 64 square root of 3. You know, I think you can probably skip this step if you want and go right to here. You know you're going to do, you know you're going to break them apart to this. Square root of 100, you know, is 10. So you could just go from here to here writing this. 2 times 10 square roots of 3 minus, and now from here to here, square root of 36 is 6 square roots of 3, and then plus 4 times square root of 64 is 8 square roots of 63. This gives us a 20 square roots of 3 minus 6 square roots of 3 plus 32 square roots of 3. So here's what we have. We've got 20 of those. Minus 6 is 14. 14 and 32. Right, 20 minus 6 is 14, and I got that plus 32. That's 47 of those square roots of 3. So what we're saying is this. If you've got 2 of these, 2 of those square roots of 300, and then you subtract 1 of these, a square root of 108, and then you add 4 square roots of 192, what do you get? Well, you get 47 square roots of 3. This is easier to deal with than this. So in this problem here, you got 5 of these square roots of 5, and the 5 is prime, so we can't break that down, and you don't know that square root is a whole number. This is irrational. Same thing with the 3. You can't break that down. So there's no way that we're going to be able to get these as like terms. So we're just going to say now that this is already simplified. Can't do anything more with that. This is just like having something like this. We might have something like, what if you had, say, 5x plus 3y, right? There's nothing you can do with that.